I would like to thank the National Science Foundation for grant number 2113469 that has allowed me, Dr. Clemons, to conduct this work along with student LaKendria Brown, where in this project we looked at the impact of sphingosine kinase 1 and 2 inhibitors on amylin. Amylin is a 37 amino acid protein that is co-secreted with insulin from pancreatic beta cells. Unlike insulin, which is responsible for moving glucose out of the blood into the cells, amylin has a role in satiety, which means it contributes to allowing one to feel full. But on the flip side of that, it is also contributing to pancreatic beta cell death and possibly neuronal cell death. So this dividing role of amylin has allowed us to focus on a project to look and see if amylin is a cell signaling molecule that can be turned on and off depending on the circumstance. We have focused on sphingosine 1 phosphate inhibitor, known as the sphingosine kinase 1 and 2 inhibitor, because sphingosine 1 phosphate is known to be protective against pancreatic beta cell death as well as neuronal cell death. So we first had to identify the proper cells for conducting the studies because there are several lines of pancreatic beta cells. And so we settled on the rat form, which is the RIN5F cells. We also looked at the neuronal cells, but we went with the neuroblastoma cell line, which is the SHSY5Y cells. We had to establish the optimal concentration for the SK inhibitors via a dose response curve because the work included the use of a novel sphingosine kinase inhibitor donated to me by a colleague from UNC Chapel Hill. In addition, we want to see if this work is implicated in cell signaling in long term in terms of what sphingosine 1 phosphate is already known to do. And so we tried to see if there's a switch point that triggers the cell death, as well as how does it contribute to the things that you see with sphingosine 1 phosphate, such as the release of calcium. I would like to thank you for your time.